Embedded Systems Laboratory, Experiment number 7, Case Structure. So, my name is Laurence Navarro from CPE109L, Section E01, from Group number 4. So, date of performance is on February 5, 2021, and date of submission is on February 7, 2021, with Engineer Cyrel o Manlises. So, again, I am Laurence Navarro from CPE109L, Section E01. So, the table of contents are, first is the introduction, second is the objectives, third is the materials, components, and software use, fourth is the procedures or the video demonstration, and the last is the PDS questions and answers. So, first is the introduction. So, what is a case structure? So, basically, a case structure is a branching control mechanism that allows different executions depending on the value of the label. So, the case structure works based on what case value the input variable matched. The case structure will choose the correct cases for execution. So, in NI-LabVIEW, case structure can be found under Structures category in the function palette. So, LabVIEW defined case structure function as one or more subdiagram or cases, exactly one of which executes when the structure executes. So the value wired to the case selector determines which case to execute. So the components of a case structure in LabVIEW are the numeric input or selector label, subdiagram or case, and case selector. So selector label displays the value for which associated case executes. So the subdiagram case contains the code that executes when the value wired to the case selector matches the value that appears in the selector label, and last is the case selector, which is responsible of selecting which case to execute based on the value of the input data. So for laboratory experiment 7, students will implement the case structure in LabVIEW for the temperature application. So the temperature application consists of single and double case structure to identify whether the value of the input converted to Kelvin as well as if it reached the temperature for hot, normal, or cold condition. So loops which are performed during the past experiments were also implemented in laboratory experiment 7. So in particular, while loop was implemented in the application, which is used to provide continuous use of the converter while running. So the next part of the demonstration is the objectives. So the objectives provided in the laboratory manual for laboratory experiment 7 that the students should attain after accomplishing the experiments are, so first is design an application using LabVIEW, second is to create a case structure, and last is to run and simulate the case of the case structure. So basically all of these three were accomplished, especially in the temperature application, wherein we modify the application based on certain conditions. For example, if the Fahrenheit reaches 60 degrees, the Boolean LED will light up, or if there are conditions wherein if it is greater than or equal to 243 Kelvin, the a certain Boolean LED will light up. So later on, as I discuss the demonstration, you can see there the LEDs of what I'm talking about. So next part is the materials, components, and software used. So the software used in laboratory experiment 5 is the NI-LabVIEW 2020 Community Edition, which is a system engineering software for applications that requires test, measurement, and control with rapid access to hardware and data insights. So the application was downloaded for free with 40 days free trial. So the next part of the demonstration or the PowerPoint is the procedures or the video demonstration of the actual experiment. So as for the video demonstration, so this is the laboratory manual for the laboratory activity 7 entitled case structure. So introduction, this is just a definition of the case structure, which is it was defined as many subdiagrams or cases but only one case is visible at a time, and it only executes only one case. So the role of the selector label, so it was discussed here, the different three parts, or I mean the components of the case structure. So next part is the objectives, wherein it was discussed earlier. So next part, so here is the demonstration. First, to open the lab view, then click create project. So lab view, create project, and then click blank project, then finish. So we have a shortcut here wherein we can already click blank VI in order to create a front panel as well as the block diagram. So create project, so new, and then blank VI. So we can skip here by just creating a blank VI here, so that the front panel and the block diagram will pop up. So there you go, the front panel and the block diagram. So next step is the two window will appear. So drag and drop some instruction code. The right side will be your front end of the application. So next, to create a case structure, right click on the left panel and click structures, then click case structure. So we can go structures and then press case structure and drag up. So drag down. So basically the case structure consists of two Boolean conditions, wherein true and false. So as you can see in the block diagram. So next part, to use your structure, you need to create a responsive control on the front panel. So right click on the right panel and click Boolean, then click push button. So in the front panel, right click, then Boolean, push button. So place push button here, and then the push button in the block diagram will pop up, and then just connect it in the so wait, let's wait. So we need to connect this inside the block, I mean the case structure. So the instruction here in step 8 is that we need to put the one button dialog under dialog and user interface. So one button dialog, and then we should create a label, I mean a string constant. So you press the button. So once you already done this part, connect this boolean inside the inside, I mean connect it in the case structure. So after that, on the false section, click the case structure and one button dialog and press the button first. So under false, dialog and user, one button, create constant, so press the button first. So run the program by clicking the arrow. Run the program by clicking the arrow symbol. The message will show if you not press the button before running. So of course, the boolean in the front panel is not yet clicked, so of course it will pass a false statement inside the case structure, and then outputs the press the button first. However, if we click this boolean and then run, it will output you press the button. So basically it outputs the true condition, which is this one, in the program. So basically that's it. So as for step 12, create a video presentation explaining how to arrive at a given block diagram and the front panel. So first we want to create new VI for the temperature. So let's close this. So first is to create a while loop. So create a while loop, and then add the stop button. by create control. So this is a stop button, so I just minimize the icon. So we should also get a clock or the weight. So after getting the clock, right click, create control. So let us minimize, so to save space. So next is the formula. So we need to input a vertical slide bar under numeric vertical fill slide. So numeric vertical so this is a vertical pointer slide. So pointer slide. So there you go. And then create the formula. So 5/9. So is divide. Create constant 5. Create constant 9. So next is subtract. Create constant 32. And then connect and multiply. Connect and then connect. So last is the thermometer, so we can find it under numeric thermometer. So let us connect the thermometer in order to see the output. So they almost similar. So basically this is just for the 12.0. So as for the 12.1, change the button into a numeric value, screenshot the block diagram and the front panel. So how can we change the button into a numeric value? So basically we need to create a case structure here. So we can create case structure here by right click, structures, case structure, and then drag. So we can create a button here. I mean create numeric control. So connect here for the condition. So as you notice, from true or false or boolean, the condition or the case selector became numeric. So basically this is just 12.1, wherein we need to convert the case structure of true or false into a numeric. So next is to modify the program to show the Kelvin value and add an additional button. So let us extend. So adjust. We need to create another case structure. Oh no. Create case structure. So you need to add the button for the Kelvin. So we can find it here under front panel, boolean push button. So let us rename as Kelvin and then connect it in the condition. So in order to get the Fahrenheit to Kelvin, we need to add, of course, add create constant 273.15. So connect thermometer to the value. So connect this here. So and then get another thermometer for the Kelvin. So thermometer. So let us rename this as thermometer Fahrenheit. And this one thermometer Kelvin. So and this thermometer will serve as the output for the Kelvin. So connect. So basically this is the 12.2. So this is the diagram for the 12.2. So next is to create a warning sign if the temperature goes up at least 60 degrees Fahrenheit. So how can we do that? So first is to create a warning sign. So basically this is a boolean. So create a boolean round LED, and then if 60 degrees 60 deg Fahrenheit. So connect this here, and then of course we will use a comparison if greater or equal, greater or equal. So if greater or equal, so connect this here, and then create a constant 60, and then connect this here. So basically if the thermometer Fahrenheit reaches greater than or equal to 60, the round LED will light up, or it creates a warning sign. So basically this is the step 12.3. So sa 12.4, we need to put a case structure to show if it is hot, normal, and cold. So we need to implement a double case structure inside this Kelvin. So let us first adjust the spacing. So adjust the spacing. So let us create a case structure inside this. So a comparison, of course, greater or equal. So let us adjust. Greater or equal, and then a comparison for equal for the normal, and a comparison for the cold, or less or equal. So there you go. And then we need to connect the temperature Kelvin. So we need to connect this Kelvin button here. So, and then connect this temperature result here. So, and then right click, create constant, which is 343.15. So next, create constant, and 342 for the normal, 342.15. And for the cold, 322.15. So let us connect this here. So and then to show the output, we need 3 round LEDs, so that it will lit up if it satisfied a certain condition in this case structure. So right click, round LED. So let us provide 3 boolean round LED, and then boolean round LED. So the first one is for the hot, second is for the normal, and third is for the cold. So let us connect this hot here. The cold, the bottom, and then for the normal at the middle. So basically this is how the module the step 12.4 works. So if the calculated Kelvin is greater than 343.15, it will lit the hot LED. So if it is equal to 342.15, it will lit the normal LED Boolean LED. So if it is less than or equal to 322.15, it will lit up the cold LED. So this is how 12.4 is done. So basically, this ends my video demonstration in laboratory activity 7 entitled case structure. Next part is the PDS and questions and answers. So there are two questions in the PDS, which first is to screenshot the front panel and block diagram, label and discuss the provided screenshot. So as for the step 12, screenshot all the front panel, block diagram, and the corresponding output. Label the provided screenshots properly. Discuss each of the provided screenshots, block diagram, and the output. So as for the step 11, so as seen in figure 5.1, this screenshot of the front panel and the block diagram. So this is the screenshot of the front panel with label, wherein as you can see, there is a Boolean switch placed in the front panel to verify or to test the case structure. So as for the next is the screenshot of the block diagram with label. So basically there are two possible output of this block diagram. So if the Boolean switch is turned on, of course it will pass the result as true in the inside the case structure, and then it will output you press the button as seen in figure 5.3 at the left side. So one button dialog was used here because since there is only one button, so in the control palette there is a two type of button dialog, which is the one button dialog and the two button dialog, which is used when you are using two buttons. So however, when the Boolean switch is turned off, of course it will output press the button first. So as for step 12, screenshot all the front panel, block diagram, and the corresponding output. Label the provided screenshots properly. Discuss each of the provided screenshots, block diagram, and the output. So as for the first one, so in the laboratory manual, there is a provided circuit or block diagram wherein it was already that diagram was already used during the loop lab experiment. So again, this is the interface of that diagram, wherein it or the front panel, wherein it consists of four objects, which are the input temperature control or the vertical slide bar, a thermometer for the output in Fahrenheit, the weight ms or an indicator or a control, rather numerical control for the clock, and lastly is the stop button in order to terminate the loop. So next part is the screenshot of the block diagram for step 12. So as you can see, this is how the front panel is made of, wherein it consists of the formula of converting Celsius to Fahrenheit, the numeric control for the clock, the stop button for in order for the user to have an option to stop the loop, and as well as the thermometer in order to output the Fahrenheit. So basically, what happens here is that when you run the program, the temperature of the input temperature of the user will be converted using the formula 5/9 minus and then parenthesis the input temperature minus 32, and then you multiply the 5/9 and the input temperature minus 32. So basically it will be output in the thermometer. So as for this 12.1, so there are modifications here, wherein in the in the in the laboratory manual, the condition is that we need to add a case structure inside the inside that circuit. So basically, we need to add also a case selector, so to provide different cases or different outputs based on the uh, satisfied condition. So first is the in figure 5.6 is the front panel. So as you can see, there is a vertical slide bar, of course, thermometer, numeric control for the clock, a conversion for the case selector, wherein if you choose one, it will output a certain it will use a certain formula, and if you input 0 or 2, it will output another formula depending on this case selector. So of course, next is the stop button to terminate the loop. So this is the block diagram for step 12.1. So there is a case selector, multiply, subtract, divide, which is the which was used in the formula for the conversion. Numeric control added for the case selector. Of course, a stop button, a vertical slide bar, thermometer, as well as the clock. So next part. So as for 12.1, so in the laboratory manual, we were asked to add a button in converting the result Fahrenheit to Kelvin. So of course, if we convert Fahrenheit to Kelvin, we should also add another thermometer for the Kelvin. So basically, the added component here in 12.2 is the Kelvin thermometer, and the the push button for the Kelvin. So next is the block diagram of the added Kelvin and the button for the case selector. So basically, in this diagram, there are two case structures inside a while loop. So one is for the conversion of Celsius to Fahrenheit, and the other one is for Fahrenheit to Kelvin. So this diagram consists of numeric control, case selector, temperature, weight, cases, divide, subtract, multiply, and numeric constants for the formula, stop button and stop loop for termination, thermometer, Fahrenheit, case selector, addition for the conversion of Fahrenheit to Kelvin, which is we need to add 273.15, and the thermometer Kelvin. So next is the 12.3. So in the vertical in this part, a condition wherein if the Fahrenheit reach 60 degrees or greater, a red a round LED should be light up. So as you can see, a round LED was added in the front panel from the previous figure. So next is the block diagram. So the Boolean round LED was connected in the thermometer Fahrenheit, and a greater or equal comparison was added alongside with the numeric constant 60 in order to be compared and determine if the Fahrenheit already reached 60 degrees and above or not. So basically, it can be the round LED can be seen at the middle part of the while loop. So next part is the 12.4. So in this part, double case structure was implemented. So by inserting a structure inside the inserting a case structure inside the case structure. So basically, the added component here is the determination if the Kelvin is considered as hot, normal or cold. So basically, this is the block diagram wherein if the computed Kelvin is greater than or equal to 343, the hot Boolean LED will light up. If it is equal to 342.15, the normal Boolean LED will light up. And lastly is if it is under 322.15 or less than or equal, so the cold Boolean LED will light up. So basically, that is the new added feature from the previous figure. So basically, this ends my presentation regarding laboratory experiment number 7 entitled Case Structures. Thank you for listening and have a great day.